is the CO2 and temperature record from the Vostok ice core, and it's showing the past 400,000 years of this record. This is a photo I took at the ice core facility of the National Science Foundation in Denver, Colorado. And they produced it analyzing the ice core that was drilled in 1998 near the Russian base in Vostok, East Antarctica. And it was a collaboration between the US, Russia, and France. They were able to go from 1950, which is the zero on the red of the plot, back to 400,000 years. And it's showing, as I said, the record of the CO2 and temperature. The irony in this photo is that somebody wanted to continue the record up to today, 2019, and drew the line, but the scale was not enough to contain the measurement of today, so continued the line on the wall. And this is telling us something really strong. So in the past 400,000 years, never our atmosphere experienced such a concentration of CO2. So when I started to work on this project, the question that came into my mind was, what is there behind such kind of information, such kind of plots of maps showing the global temperature, showing the increase of temperature in the world, or projection of sea level rise for the future, and so on. So I got interested to understand how this kind of information is produced, who is the people working on these kind of things. So how do we know what we know about the climate and climate change? So let me tell you a story, which is my story through climate science that started a few years back. It was the beginning of 2016. I was finishing my PhD, and as part of it I was visiting the Columbia University in New York. In New York City, besides great university and research centers, there's also a very famous photography school, which is called the International Center of Photography, where I always dreamt to go. So I decided, despite the challenges, that I wanted to take a class. So I signed up to documentary photography, for which we had to develop a project. And I'm sure that many of you are familiar with the last months before the submission of a PhD thesis. And I had absolutely no time to go around the city and take photos and work on the photos and so on. So I spent several days of frustration because I didn't know what to do. But then one day, when I stepped off the bus that was taking me to work, and I wasn't working in the main campus of Columbia in northern Manhattan, but rather 30 miles north at the Lamont Doherty Earth Observatory. So when I stepped off the bus, I realized that that was the place I had to document, because I was actually working there, so it was easier. And the place, it's really interesting because it's an historic research center, very important for geosciences in general, and of course also for climate science. It's located in a fantastic place. It was the villa of a rich Wall Street banker, Thomas Lamont, who died in 1948. And after his death, the wife left the property to Columbia University, and the research center started. So very beautiful location on the cliff of the Hudson River, in the middle of wild nature and full of weird people, which was really good for my project and full of bizarre stuff around. So I started to go around and take the photos that you are seeing now. I've seen the sediment core repository, which is the biggest in the world, containing thousands of sediment core drilled from literally every corner of the bottom of the oceans, from which scientists are able to reconstruct the climate of the past. In this case, they can go back millions of years. They found out that analyzing a type of organism that lives in the ocean and that you find in the sediment, the foraminifera. This one is building the shell out of carbon, and depending on the temperature in the ocean, inside the shell you find a certain quantity of oxygen isotopes. So by measuring the quantity of isotopes in the shell, you can reconstruct the temperature of the ocean of that time. So to do that, you need complicated machines, like mass spectrometers, which are able to date your sample, depending on the depth of the core, and is able to tell you the chemical identity of the molecules or compounds that you are analyzing. And to build this machine, actually, you need to know also a lot of technology. Most of the time, the scientists themselves have to build the machine because you cannot find exactly what you need out there. So there, for example, I got to know Jesse, a young scientist who was working on the mass spec, and he was spending many nights in the lab because once he started an experiment or a measurement, he had to stay there in control. So he was training during night on climbing the step of the building. But also I met Brandon in the 3-ring lab. So it's not as fancy as the geochemistry lab full of high tech. In this case, it's more low tech. It's more a carpenter workshop. And these people here are analyzing tree rings. So basically they take a core from trees and they analyze the width of the tree ring. So basically when you see a tree ring which is very narrow, it means that for that plant in that year there was some stress and so it couldn't grow properly. And so you can detect the temperature anomaly of the past. So by analyzing the rings, dendroclimatologists are able to reconstruct year by year the climate of a certain region where that tree was grown. And they go in very remote places, in pristine areas, to understand how was the climate without the interference of the humans, or they can also analyze plants that are growing in urban areas. And Brandon, the guy that you see before in the picture, was also telling me all the nights he was spending, also during the weekend, to clean his samples, because there's a lot of manual work. You have to send them, to clean them, to glue them, to catalog them. So he was spending weekends having some whiskey, listening to music, and working on his archive. So at the time, I didn't realize I was working on the project that I'm talking to you today. But little by little I understood that this could have been a good way to tell people, to show people how climate scientists are working, what they are doing, and which strange places they are working, in which remote areas they are doing, what are their challenges and achievements. And mainly I decided that photography could have been a nice language to use to tell this story. And so that's how I started to travel to different places. So I went to Mount Cimone, which is a mountain in the Italian Apennines between Bologna and Florence. At 2,000 meters, there is this observatory run by the Italian National Center of Research, where they are monitoring greenhouse gases in the atmosphere. It's the only observatory at the south of the Alps, part of the global observatory watch of the WMO. Here I spent a couple of days with Paolo, a scientist running the observatory. We were sleeping on bunk beds, we cooked pasta at night, we had some wine. And while I was watching the panorama and see the lights of Florence in the horizon, Paolo was actually calibrating a new instrument that wasn't working properly, so he spent the whole night working, and instead I was tired, I went to bed, so I could relax. And it was actually very cold. It was August in the super hot Italian summer, and Paolo is coming back every few weeks, also during winter, and with bad weather, basically it's an alpine hut, so it's not so comfortable. Then I went to Mexico City, at the Autonomous University of Mexico, the Department of Atmospheric Physics. So one of the biggest urban areas of the world, 35 million people living there, one of the most polluted. And scientists are working on air quality. They are studying how pollution, how human activities are affecting the quality of the air, how this is affecting the spreading of pollens, for example, and how this is correlating with human health, like allergies or lung diseases. Then I joined a team of scientists of the Max Planck Institute and of the Brazilian Institute for Amazonian Research. And we went to the Amazon Tall Tower Observatory in the middle of the Amazon forest. It's literally in the middle of nowhere. It's 150 kilometers from Manaus, which is a big city in Brazil, in the middle of the forest. And to reach the site, we had to travel one day from the city, so 6-hour drive in between an highway and a white road. Then we had to jump on a boat for an hour, and there's no connection in the forest, so you have to coordinate before with the person that is coming to pick you up at the river. After 1 hour on the boat, there's a pickup coming pick you up and taking you literally through the jungle and reach the camp, where we were sleeping on hammocks at the Brazilian style, and I spent a week with them there. And on this tower, which is 325 meters tall, 1 meter more than the Eiffel Tower, we are really proud to say that. And scientists are trying to understand the interaction between the forest and the atmosphere, which is the role of the Amazon forest in the climate and water cycle of the planet, and also to understand the role of the vegetation of the forest in the global cycle of greenhouse gases like CO2 or methane. They're also interested to understand how the volatile organic compounds emitted by the soil and the vegetation, it's interacting with the formation of aerosols and clouds in the atmosphere, which is one of the part of the climate science where we have the most uncertainty. So here, for example, I met Stefan, who is one of the director of the camp, and to me he resembled like a modern Alexander von Humboldt, an explorer able to cut his way through the jungle with a machete, fishing piranha on a river, and then jumping back his laptop and working on a paper on the interaction between the biosphere and the atmosphere. I also met Dennis, a young scientist. He was studying VOCs, volatile organic compounds, was climbing the tower, 1,500 steps up and down, twice a day, to collect his filters and replace them. So he was quite in good shape when I was there. And then more recently, I've been to many places, and I've been to Caltech in Pasadena, where a group of scientists are working on a new and revolutionary climate model. I've been to the European Centre for Medium Weather Forecast in Reading, out of London, to visit their supercomputer and their data archive, the weather data archive, which is the biggest in the world. And the supercomputer is used to make weather forecast, also seasonal forecast. And beside that, I went also to Cheyenne in Wyoming to visit another supercomputer run by the National Center of Atmospheric Research. In this case, one of the most powerful computer that is doing climate modeling and also projection for the future. I've been to the National Center for Atmospheric Research in Boulder, Colorado, to see their airplanes they use for, they have a super expensive jet airplane that is turned to a scientific airplane, and they have a former military C-130 full with instruments, and they fly in the atmosphere to take measurements. They follow storms, hurricanes, and so on. I spent a day in a freezer, in a huge freezer, always in Colorado, in Denver, where this picture came from, with Jeff, a scientist, taking care of one of the biggest ice core repository in the world, and he's working at minus 36 Celsius to analyze the ice cores. We spent a morning there. It was really, really, really cold. And this guy is working there since many years, taking care of one of the biggest archive of ice, simply ice. But in order to maintain the ice properly, you need to have a very big freezer, and it must work very, very well. I visited also NOAA. We went on top of Niwot Ridge at almost 4,000 meters to see the station where they started to monitor CO2 concentration in the atmosphere. And I was there with Dwayne, another scientist working since decades on CO2 measurements and also producing standards, which are aluminum cylinders filled with reference air with a certain concentration of trace gases, and he's sending these cylinders in every station of the world to allow the scientific community to make measurements calibrated on the same type of air, so that we can monitor CO2 in the world in a very precise way. And finally, I've been also to NASA Jet Propulsion Laboratory also in Pasadena, where they are controlling an instrument that is on board of the International Space Station, which is observing CO2 concentration on the atmosphere globally. But also they're working on a rover that they are going to send to Mars next year. And scientists, beside the engineers building the rover, are trying to understand the climate of Mars. So after all this traveling, and there's still to come, besides making me worry about my carbon footprint for this project, this gave me a great privilege to see really interesting things, like how difficult and complicated can be the work of a climate scientist. The same as many other scientists in different fields, but still very, very complicated work that needs to be done very precisely in order to allow the whole scientific community to understand precise things about the climate. Also realize that we are relying on certain type of people that I like to see them like guardians of the climate knowledge, like the people I told you, Dwayne or Jeff or Paolo, working since decades on a single thing. Could be preserving the ice cores and analyze them, or making standards for the whole world to measure CO2 emissions and concentrations. But still, single person that are doing their job with a great precision in order to allow everyone to do a good job and understand the climate system. Also, this gave me a great sense of unity, of belonging on this planet, seeing how all these people are working together without any boundaries, with a lot of diversity from background, culture, knowledge. And I can see how this diversity is actually the key to advance the knowledge we have in science. And also, the last thing is, I think I understood that how this different language, like can be photography or narrative, in the case of my project, can be really important to understand the complexity of the era that we are living, and that is affected by many change, like the one on the climate. So thank you very much for being here and for listening, and let me thank, of course, also the Richard Carson Center for this opportunity to be here and work on my project, and also thank to Fausto for the very nice introduction before. Thank you.